Hello, and this is the answers to our fluids thermal review game. Question number 1, first part, 6.02 times 10 to the 7th pascals. Part 2, 1.2 times 10 to the 4th newtons. Part 3, 6.01 times 10 to the 7th pascals. Number 2, Part A, 768 meters per second. And Part B, it would decrease. Number 3, Part A, the force is 63.9 newtons. Part B, the acceleration would be 5.54 meters per second squared. Number 4, Part A is 76 meters per second. The gauge pressure would be 2.76 times 10 to the 6 pascals. And P2 would be 1.86 times 10 to the 6 pascals. Number 5. This one got a little messy here with a quadratic, but I started out here on the top using rho GH equals 1/2 rho V squared and found that for Vx, and then did D equals V times T, and D equals 1/2 GT squared in the vertical direction to solve for the time. Then I set them together for a quadratic, and I got 6.93 meters for the distance D. So that one, kind of tricky one. Again, I'll go through my work here. And my final answers. Sorry, I can't focus this any better. Then number 6, we had a PV diagram where the temperatures in each case I found using PivNert. And so I got temperature at A is 7.2 Kelvin. At B is 21.7 Kelvin. At C is 12.6 Kelvin. And at D is 4.2 Kelvin. Number 7. Delta U is 0. The work is the area enclosed. So I got 100 joules, and that would be negative because it's work done by the gas. And the net heat from delta U equals Q plus W, I got to be 100 joules positive, so that's heat added. Number 8, PV diagram. Kind of zeroing in on my chart here. I'm going to just check your answers. For process A to B, I had 361 joules for delta U, 602 joules for heat, and negative 240 joules for work. For B to C, I had negative 227 joules for delta U, negative 227 joules for Q, and 0 joules for the work. C to D is negative 207 joules. Q is negative 349 joules. And work is positive 140 joules. And D to A is 75 joules, and 0 joules. And there's kind of my equations I use. And this was given that it was 2 moles. Number 9. KE is 1/2 mv squared, set that equal to MLF. So I was able to find the mass to be 0.09 kilograms. And then if I set 1/2 mv squared equal to MLF, I would get 4,080 meters per second it would have to be. Number 10, set up GP equals KE, which equals the work. So my GP at the top, mgh, equals mg mu times the distance. So I got mu is 0.714. And to figure out how much ice we could melt, I solved for the mass, setting change in PE equal to heat, MLF, and I got 0.074 kilograms. Then number 11, the efficiency, part A, would be 76% efficiency, and for part B, 77%. And then number 12, heat would have to be added because the change in internal energy increases while the work is negative, so heat must be added for that to work out. The change in internal energy of the gas, I did delta U equals 3/2 nR delta T, and I got 2.8 times 10 to the 4th joules. And how much heat is transferred, I did delta U equals Q plus W, noting that the work is the pressure times change in volume, negative, because if you're, depending on if your work is positive or negative there. So I got Q is 4.67 times 10 to the 4th joules. Okay, that's all. Thank you and good luck studying. Bye.